have your scenarios where you're doing maybe smaller types of workloads, but then with Cloud Spanner, it's a bit more of a global scenario if you're looking at the type of rollout. So again, it could be multiple regions, but sometimes you may need to do some things in terms of transactional integrity across a really wide range of transactions. And so from that standpoint, Cloud Spanner is something to be aware of because it's pretty unique in terms of what's available in the industry, especially as a managed services offering. And then for the NoSQL databases. So we have the Cloud Data Store, and so this is really good for hierarchical database environments, sometimes mobile web. You see it used sometimes as the back end of some content systems. So storing user profile information, things where you have a lot of reads, and also when it comes to gaming, so maintaining game state, the real-time state inside the gaming environments. And then with Bigtable, we see this a lot with financial services, or if you have extremely fast-moving data. So for Internet of Things, if you have the information coming in your streaming pipeline going into a real-time database, then Bigtable would be useful. So again, heavy reads and writes and events. Cloud storage, it's not a database, it's really our object storage system. And this is useful if you're doing backups and managing media binary objects. So things you would do in the kind of an object storage environment. And then finally a BigQuery, which is our managed data warehouse environment. And so here, because it's managed, you're able to pay by query and just little costs in terms of storage. Sometimes instead of actually doing your queries on your own on-prem systems, maybe size for some of those like month-end analytic activities in your warehouse, you can have just-in-time scalability based on your query. So one query may actually take 100 POCs, and another one might just require a really small number. You have control over the utilization there, and so again, it's still fairly unique in terms of what we're able to offer. So this is our managed services inside of GCP. I'm just going to go to the next slide. And this is kicking off a little bit of what you'll hear about more today, which is how do you leverage the Google Cloud Platform if you have commercial products or open source products, bring your own license. So in some cases, we allow customers to run on our compute environments. You can bring your own license. But we have some unique partnerships, including our partnership with SAP. And this gives you the ability to combine how you are accessing the functionality. So within the environment, we use our Cloud Launcher and also the Cloud Deployment Manager. And in that way, you can control how you're deploying some of these resources to support whatever topology you want. And this includes these scenarios where you're leveraging your full ecosystem, where you have middleware and other front-end application components connecting to the database environment. So we're focusing on databases today, but just keep in mind, from a compute standpoint, we support migrating and operating both the front end and the back end. The scale-up scenario with compute, I just wanted to highlight one shape we have available in terms of storage. A lot of people are aware of leveraging cloud compute platforms to scale out large clusters, but sometimes you have a different type of requirement in terms of the resources you need. And so we do actually have high memory. In this case, it's called a mega memory in compute shape. So you can configure one of these 96 virtual CPUs and over 1 terabyte RAM. You can configure those, or a set of those, for some of your database workloads, including certain types of use cases for SAP HANA. So today we're here at SAP Labs, great, and then we are also going to hear from one of the product managers of SAP HANA to talk about running in this manner on the Google Cloud Platform. Because there's a lot of information you may have seen. Is anyone a data engineering certified person on the Google Cloud side? Or have you taken any Google Cloud training classes or Cloud Onboard? Okay, Okay, yes, we have a couple in the back there. So sometimes access to the managed services are available, but access to find out the best use cases and the best deployment models for some of these scenarios where you're actually leveraging Google Cloud for compute to run your database environments, that's not always easily available and accessible. So we're doing that today with SAP. So you can run SAP HANA, HANA Express, Cloud Identity, other products, the middle tier, NetWeaver, other things you can actually run on GCP. And then we also have integration from the SAP standpoint, and he's going to step through, not just from a product standpoint, but he's going to talk about the different types of database use cases, environments, and then he's going to drill into some of the scenarios related to SAP HANA for those use cases.
At least have a few of them. So what I'll try and do in this session is I'll take you through SAP at a high level, just to give you a perspective. It's a pretty complex organization, has been around for more than 45 years. This location is our SAP Labs organization. Some of the things we do out of here is we have our co-innovation lab right behind you to the side. We have a number of different engineering teams focused on things like blockchain, machine learning, and those kind of things. In one of the buildings, there's 8 buildings around on this campus. It's kind of a local hub for user experience. So user experience at SAP, the managing director for that area sits here as well. So kind of, and obviously a large part of our HANA engineering organization is based here in Silicon Valley too. One of the projects we're running right now, and we won't discuss it today, but I'm happy to discuss it either at pizza or when we have some beers or something later. Just discuss some of the other things, like we are developing a new version of our managed cloud service out of this facility as well. So lots of development and things happening here.
Yeah, charging.
So to start somewhere, right, is when I was hunting around for a good way that doesn't look like too much of a corporate briefing on SAP, right? So just trying to find a way for you to get to the scale of SAP. So the organization has been around for 45 years, started by 5 people who left IBM, right, with the idea to start developing packaged applications instead of developing the same financial management application over and over and over again. So broke away from IBM, formed their own business, really focused on, at that time, the finance part of the house, built out an ERP application. And today, some of the stats we have here is that SAP is really widely deployed throughout large corporates globally, right? So the stat we have is that around 76% of transactions, sales transactions, somehow touch an SAP system somewhere, right? So that's a massive scale. I mean, I think every company has a slide where they give you the Forbes 100. So generally, if it's a large organization, if it's a multinational organization, if they have to do things like run tax or payroll or financial transactions in multiple countries, they have distributed supply chain, there's a pretty large likelihood that it runs some kind of an SAP system. And then over the last 5, 6, 7 years, the organization has been focused on modernizing our portfolio and transforming it for cloud, right? So like, I guess everyone in the room here is wanting to move over to new business models, getting challenges from global environments. Our customers want to get out of the data center businesses. So fundamentally is we've turned our portfolio into something that 5 years ago was pretty much an on-premises business into something that predominantly and quickly growing into a cloud business. So in this location here, we have about, in the Bay Area, we have about 3,300 employees. Generally a mix of traditional SAP folks, but also some of the acquisitions we've made in the last few years, so SuccessFactors, Concur, Ariba, that all kind of make up the portfolio. And here you'll see that the organization is a very diverse organization. Obviously, being European-based, we have people with my kinds of accents running around here. It's kind of funny. Someone today looked at my avatar and suggested that I change it to the villain in Black Panther. Right? So saying I sound kind of like Claw, right? So it's they call the guy Evil Rudy. So I took that on today. So they're very diverse, people from every kind of in different countries, different ideas, working on different projects. So quite a cool place to work. quick history lesson here, right? So just to give you a perspective, we said 45 billion market for 45 years, and I'm doing this just to get you a perspective here, right? So when SAP was introduced, kind of in the mainframe era, and you can see the organization has been sort of shifted the main application at every big shift on the compute side, right? From, and I don't want to go into when client server and distributed computing and all of those kind of things, but R3 was kind of at the time where client server computing was popularized, and now with S4, which is kind of either you could call it the digital or the cloud era or the software as a service kind of era, where we've had significant architectural changes to the way that we've rolled out our applications. So when we rolled out R3, as an example, SAP wasn't at the time a database organization, had a pretty good relationship with a company called Oracle, and at that time, you know, the expansion of those relational databases were pretty much up to SAP pushing those applications into market, right? So all the way seen and done most of the major compute shifts. So if I zoomed out and gave you a 50,000-foot overview, this is kind of what our portfolio focuses on at a high level, right? So integrating suppliers and networks, with the customer experience, leveraging IoT and big data, all connected to a single platform. And there's a few ways to present this, and this is another way that we like to put it on the page. And I thought that I'd have used this one because it's a bit more product-centric and doesn't smack too much like a marketing slide, right? This is slightly better. So on the left-hand side there, you can see the main core of our application portfolio, which is it's called S4. And you can see a range of applications derived out of that. So the way that our technology portfolio works is we have a core system, the digital core, as we call it, and then we have a number of line of business applications that we develop on those, and there are 25 different industry variants of that application, right? So, and fundamentally the same code base. So it's the same thing, and it gets rolled out 25 different times. And you can see as we move from the left to the right, the portfolio becomes a bit more technology-centric, right? So you have the applications, and towards the middle, we have analytical solutions. Towards that cloud block there is where we're going to spend a lot of our time on, at the base of it at least, is we have, we focused our energy on developing a cloud platform, like to integrate either the different lines of business and the SaaS applications we have all the way on the right-hand side. So if I had to kind of summarize that, everything from fully fledged end-to-end applications in HR, finance, CRM, to SaaS applications that have certain functionality, and then into a portfolio of technologies that either underpin those things or that could be used without, right? And just to kind of introduce some topics here is the cloud platform and the HANA technology is now foundational to most of these things, right? So when a customer, for example, deploys S4, they will be deploying the HANA database technology. They will be using the cloud platform to integrate to different things, and that's kind of the way it stacks up. And when it comes to GCP, we've obviously had an effort to certify these technologies, to pick the right shapes and compute size, and work side by side to make sure that customers that are used to running SAP on premises has an ability to do a lift and shift to a GCP environment, right? So, and the reason we do that is pretty simple. That's exactly what customers want to do. They want to leave their data centers behind. They want to run a modernized stack. So fundamentally, the partnership for us with Google is important. So, and that's kind of what we wanted to say here, right? Is that fundamentally our flagship products now run on GCP, and product is a broad term at SAP, right? Is if you think ERP is a product, and the database is a product, and the middleware thing is a product, we've had to go and certify a number of these technologies for GCP. Like we would, for example, in the old days, certify something on a specific flavor of Unix or those kind of things. But these integrations and certifications kind of work the same way, right? Is we need to make sure that they perform, we need to make sure that we can support them, and we need to make sure that we have back-to-back agreements with everything. So, and we kind of referred to these a bit earlier, right? Is there's a number of things outside of the integration that we also do, right? Or the certification effort. And this is a kind of a small slide, and I almost don't want you to just spend too much time on it, but fundamentally there are about 4 areas, there's probably 5 areas that we have active co-innovation projects on now. So we mentioned G Suite and services, so we integrate Google G Suite and services into the application portfolio. We have
co-innovation projects in the Leonardo world. Leonardo is our machine learning and AI architecture. What's interesting about Leonardo is it's not just another general purpose one, it's a piece of technology that underpins our ERP, right? So, for example, if we do order processing, we can use machine learning and AI inside of the application. We don't have to move the data out, do something and bring it back in, but we then work with Google to certify things like TensorFlow, those kind of things at the back of it, into the back of that. Cloud Platform is our PaaS strategy, right? So that's where you extend and enhance SAP applications. And then finally is the things we talked about earlier, which is integrating the application tool sets with the infrastructure as a service. Stop me at any time and ask questions, right? So it's more than comfortable for you to do that. Okay, so I'm going to drill into databases now. What I'm hoping to do in the next few minutes or the next 30 minutes is to kind of explain our vision and strategy around databases. I've already said that these databases are available in Google Cloud Platform. From an operations perspective, there's a number of different ways you can consume them, and we can talk to that. What I wanted to do now is just give you our perspective and why we have yet another database, right? So today, just before the session, I went into GCP, I went into Launcher, I clicked on databases, and there's 66 of them on Google Cloud Platform, right? 66 different databases, right? So, and I often ask myself is why do we need as many databases, right? Does the world need 66 different databases? And when I speak to customers, often their answer looks something like this. The reason for this is that many applications that we deal with have a database per application that they have today, right? So if you think about it, it's these things aren't perfectly integrated. No one picks a single database and bases their entire application architecture on top of it. And it gets worse as everything now is microservices, and we have some people in SAP that tell me that you have to have a different database per microservice, and so this picture doesn't get easier. And what that means is that tools at the different databases, and every night they would just snapshot and copy those. They got more sophisticated over time, used ETL tools and those kind of things to update those data sets. So again, a different kind of technology from a user perspective, very similar to the relational technologies. Mobile databases, so if you want to run one of these, you get databases that are designed and built to run specifically on these. We build those too, right? So the kind of database there needs to be slightly different. It needs to back applications. The most important thing that those databases have to do is synchronize data to a central hub, right? So it doesn't help you to build a mobile application and data stays on the device. It needs to feed back in. And again, different design principles for those. Embedded databases are the ones we see in IoT devices, so in a mobile gateway and some of those kind of things. Then you go to distributed computing for big data. So we have data engines that sit on top of the Spark engine for processing in HDFS and those kind of things, and that's a different kind of database. And then finally you have the streaming engines. Anyone familiar with the term complex event processing? So the CEP kind of technologies, which kind of, the difference with a database and that, the way that I normally explain it is, when you want data out of a database, you write a SQL query, it fetches data, returns it to the application. The streaming engine is different in that the data flows through the query. So you write a business rule and the data flows through that, right? And kind of pops up and says, hey, I found that this, and this event happened based on the data. So one example there would be on an oil rig, monitoring different alarms that might go on and off and understanding whether the pattern in the alarms is actually problematic or whether this is just normal noise, right? So finding needle and haystack kind of scenarios. So we found that most applications fundamentally need bits of all of these for the next economy. And what we started looking at is saying as well, how would in-memory change this picture, right? And to kind of, just to not bury the lead, the technology HANA is an in-memory technology, and what it would do for us is kind of speed up data processing in a meaningful way. And the picture I have here just gives you a perspective of, well, if you look at traditional disk-based access versus in-memory access, you can kind of see the factor of improvement as we go up the stack, right? So kind of an interesting thing, right? So what we did then is we said, well, okay, if we took a database and put the entire thing in memory, took out anything or didn't build anything that assumed that it would have to write to disk at some point, right? So instead of saying, well, write to disk, put it in memory, memory is the primary persistence, what would the benefits be, right? Now, and just to kind of get to that, is just to illustrate the difference here. This is an analogy that I stole from a friend from London, right? Just to kind of get the same picture out here, is that imagine drinking beer. Drinking the beer is kind of like bringing memory to the CPU. That's kind of the distance that you have with an in-memory computing engine. If you had to go a bit further and get it from the table, that would represent kind of the distance from you to the L1 cache. If you had to go fetch the beer in the fridge, you'd have to walk to the fridge. The L3 cache is about 9 meters away, right, if we sort of visualize that. If you had to go to RAM, main memory, you would have to go to the shop. And if you had to go to the brewery, which is the disk, this is kind of the distance you have to be. So kind of visualize that and say, well, that's, if you had to think about disk-based access and memory-based access, that's the distance you'd have to travel to get to the same level of thing. So our thought was, well, if everything's in memory, it changes things dramatically, right? And this is kind of the analogy that someone used for me is, the kind of extreme speed that in-memory databases allow you to do is it allows you to take away a lot of the design considerations and limitations that your application has completely, right? So, and the question there is, well, where does a 600-pound gorilla sleep? And the answer is where it wants to, right? Exactly where it wants to. You can do what you want as opposed to sort of thinking about your design of your application to get to that. Okay, so turning this over to the benefit this had for our applications, right? So I thought that, well, how do you illustrate the benefits of an in-memory database? Now, what's interesting about our technology, and I'll get to that in a second, it's an in-memory database. It leverages columnar technology, but it's designed for online transaction processing, right? So the idea is you can run an application on top of your data warehouse. You don't have to ETL the data around. You don't have to move it. We basically run data warehousing workloads within the application. So that means you can do machine learning, AI, the predictive stuff on the same data that your application is running, right? So that was the design principle behind this. So for us, what you're staring at here is the data model of our ERP system before we ported it over to HANA. So every little blue box in that picture was a table inside of the ERP scheme. There's about 80,000 of those when we started the project, right? And a lot of those are redundant. They are balance tables, they are conversion tables, they built for performance, they built for a variety of different reasons that the application developers couldn't just query, put all the thing in a relatively flat schema with large tables, right? They had to do a lot of things and build a lot of redundancy to get the application performing the way it needed to perform. So, long story short, we had R3, we had ECC. ECC we certified our SAP ECC system for HANA and got a benefit straight away. So operational reporting in an in-memory database that's columnar is a lot faster, but we didn't see a massive performance improvement on the transactional side, right? Because this is what we had to deal with. You still had to update all of in-memory is good, but it still doesn't cover for a design flaw that we have here, right? So reporting was great, but fundamentally we had to change a few things in the system. And what we found is we could pretty much get rid of all of the aggregate tables, and we sit with a schema that looks like this today, right? And fundamentally, the reason for that is that we don't have to persist balance tables. We can fundamentally run aggregations directly on live data now, right? So we can, instead of create, and where we needed objects, we can create views, so non-materialized views to the data so that the application could function as is, right? So now think about this. So this is great from a data analysis and data architecture perspective. Everyone that's designed a data model in their life says that's awesome, right? Less tables, less indexes to manage, the backups are smaller, that's great. From a productivity perspective, that means your developers have to maintain a much smaller code base, right? So from a productivity perspective and a time to market perspective, this makes a massive difference, right? And this is why we were able to release versions of the technology pretty quickly. So concept-wise, remember the first slide we had, this is the picture that we have in mind, right? Is when we designed HANA, we looked at, we wanted the logic for all of the applications in a single platform on a single data set. And for us to do that, we needed to leverage columnar compression, and we had to use in-memory technology, right? So Anyone that's worked with columnar stuff before tells you it sucks for OLTP, right? Stay away from OLTP workloads on this. A combination of what we've done with in-memory, the columnar stuff, and the fact that we never assume that a transaction has to persist to disk. Disk is a backup for us. Yes, it's a fully ACID compliant system. You don't trip the power and the data is gone, but fundamentally we log to disk as opposed to trying to maintain. Let's say if it's even our own technologies, right? As we acquired Sybase 6-7 years ago. The Sybase database has a 100% in-memory mode. It's very similar to the Hackathon architecture that you saw on the Microsoft side, where we can persist everything in memory. We have the smart, fast snaps to disk into the disk-based tables. This thing is just different. It doesn't have the code path that those other databases have and have had for 40 years, right? So it's an entirely different architecture. Okay, so what does that do for you? It hopefully simplifies everything, and the benefits you have at the bottom, right? So when you do this, you don't have to wait for any data access and processing because all of the data is always in memory. All application logic, including OLTP and OLAP style logic, runs in the same application. So instead of doing predictive analytics outside of the system or waiting for it, right? So what most of us do is our business processes are built for that delay, right? So at the end of the day, there's a job that kicks off. It moves data out of a bunch of transaction systems. The risk department gets it, they run analysis, and they present the risk to the board the next day, right? With this, you can build your application, you can build those risk assessments into your system live, right? So they don't have to happen after the fact. I'll talk about the other one in a second. All data types processed in one system. So what do we mean with that? That means spatial, graph, text. What we've done with the system is instead of looking at those as different database workloads, we've looked at those as data processing engines, right? And I'll show you a picture of that in a second. So, I mean, just a quick slide, I'll skip through this quickly. What that now means is that this technology, this HANA database technology, is at the core of every single one of our applications now, right? So what it does for us is internally, we base our applications on it, our cloud applications are based on it, our ERP applications are based on it, and we obviously see a number of partners and customers developing custom applications on the technology and homegrown applications on the technology. We published a reference architecture for this. So startups that want to develop applications to sell into that SAP portfolio, they leverage the same framework as we do, right? Which is kind of, if you please go back.
I have a quick question. Like, what kind of columnar database you are using?
What kind of columnar?
Yeah, what kind of columnar database you are specifying that you're using columnar database, right?
Yeah.
So what kind of
Well, it's our own technology.
Oh.
We didn't leverage some open source thing, we built it from the ground up. Now, what helped is we acquired a company called Sybase in around 2010, and they had one of the leading column store technologies in market. It was called Sybase IQ. Right now, we didn't take the code for IQ and just jumped it into the project like we could have. We redesigned the system entirely for an in-memory model. And it helps, right? If you think about the way the data is organized in a register and in a cache, it ties quite nicely to the columnar way of dealing with things, right? So that's kind of the one benefit. So what I was saying just before the question is that obviously a lot of our partners now build add-on applications based on HANA, based on Cloud Platform, and they sell that onto SAP customers. And there's like 350,000 of those globally, right? So from an ecosystem perspective, there's a massive opportunity for people to get involved in this kind of architecture, right? And if we do a good job, a lot of them will end up in GCP. High-level picture here. This is, if you look at the HANA platform, there's a few things that we also did that we thought was interesting, right? So remember I referred to data processing. So if you look at this picture at the bottom, is the layer at the bottom is everything that you'd expect to have in a database, right? So the columnar and OLAP engine at the bottom there, multi-core, parallelism, multi-tenancy, the data modeling functionality, the open APIs, client interfaces, Java drivers, Node drivers, Go drivers, that's all in the database layer of this thing. So anything, if you expect to be able to use a JDBC and ODBC connection and connect to your database, that's all built into the bottom layer of the architecture. When you go up, one of the blocks that I think is pretty important is this one here, the Advanced Analytical Processing block. Now, remember I talked about those 66 different databases? Our implementation is different because we don't instantiate those as different databases. They are data processing engines on top of the data we store in HANA. So for NoSQL-like functionality like graph and spatial, we have a graph engine sitting on top of the platform with graph query language. We have a text analytics engine. So instead of thinking about these things as different databases, instead say, well, okay, I'm going to run Neo4j for I'm going to run Neo4j. I'm going to run for graph. I'm going to run a different spatial database for this. I'm going to run the streaming database for that kind of thing. What we have is engines sitting on the same copy of data, right? And that data is in memory. And then finally, all the other pieces that you need. We have engines that ingest data from other third-party systems. We have the data distribution, data virtualization techniques. And then the other interesting thing is the HANA environment comes with a built-in application deployment environment, right? So its own IDE and an application environment that's kind of built and designed for an in-memory model. So an in-memory model, right? So what most developers ask me then is, well, I have my own developer stack, how would this be different? And what we've done is we've basically taken the Cloud Foundry PaaS model, and we've instantiated here in a microservices model. So if you have a Python-based application, all you do is you push the Python application into our deployment environment, and it runs as it would in a separate environment. So it feels like your own PaaS, your own cloud-based application environment that you have in there. And I can show you a quick demo of some of the tools a bit later, just so you can get a perspective of this. So not just a database, a fully fledged database with an application delivery environment plus IDEs and support for things like Java, Python, and those kind of things built in. We're actually working now on a Python stored procedure language that we put in. So we have SQL stuff today, we have R built in already, but we want to make sure that on the back-end side we can have Python in there. And a lot of the application techniques we see are slightly different because instead of doing a lot of data processing in your application environment, we push that down into the data environment. So from a processing perspective, instead of running a sort of a cursor in the code that calculates some things, often this design model pushes the data processing into the database, right? So where you have lots of memory and lots of processing. So that shape that you had there, the almost 2 gig memory shape comes in quite handily for that. The next few slides are just kind of concepts, just to kind of give you a perspective of some other things here, right? So I already talked about this. That's a blow up of the analytical engine side. So instead of having a NoSQL database, we have NoSQL capabilities built into the engine. Instead of having a specific graph database, the graph engine is built into the technology. And you can kind of see a set of different environments. We have a set of predictive libraries, different kind of memory capacity. The difference is they still have the code path to the disk, they still have tons of overhead, right? And fundamentally you're storing data twice. You're storing data in memory and on disk, and you're storing it in a pretty inefficient way on disk as well. So when we look at the HANA environment, is fundamentally data is only there for persistency and asset compliance. We assume all of the data, your entire working set is in memory all of the time, right? So when you query data and it's not in memory, we load it into memory and then we process it. What's different about HANA isn't just the use of RAM, it's the optimization between the caches and the CPUs, the NUMA properties that we need to implement there, the fact that it's columnar gives us a nice compression. Now, so practically what that means is if I have a customer running the SAP ERP on a, let's keep it clean from a competitive perspective, runs it on a Sybase database technology, right, which is the one we have, which is very similar to SQL Server, DB2, and Oracle. We found that we could compress 30 terabyte ERP systems to about 3 terabytes in this model, using the compression and those kind of things. So often the question is, well, it's going to be bloody expensive to take my disk-based database and store all data in memory. Well, not if you have to store it in a much smaller footprint, right? And if you can scale it out, which you can for OLAP environments, you also don't need the massive t-shirt sizes. I mean, from an OLTP perspective, you always lean towards scaling up rather than scaling up, but that's a conversation that I don't want to have with the Spanner guys right now. Okay, so we talked about this. Quite often, the largest latencies that you see in these data processing environment is the picture we had when we started off with, right? Is for you to make a decision. So let's think. Think about some questions.
Yes.
Think
about some questions.
So let's say, for example, one of the examples we normally have is in capital markets, trade analytics and risk analytics, right? So if you think about the model there, is trades happen throughout the day in all sorts of real-time systems. But typically what these banks do on a night-by-night basis, they do the risk analysis and they go to the next trading day with a strategy. So when you have the 2008 financial meltdown, which happened in seconds, that kind of processing doesn't help, right? Is the fact that you have to do the ETL, the data movement, the kind of standardization of data, and you can't just do it directly on your system. That causes massive problems. So our HANA systems now are implemented in financial institutions like E-Trade and some of those guys to just deal with trade risk analytics on a day-by-day basis. We talked about this. The nice thing about using something like HANA is you don't have to use multiple different databases underneath your application, right? So you don't have to move data from one database to another, just service one application. If you wanted to introduce geospatial functionality into your application, why would you have to go and implement yet another database, right? So that's the kind of thought process that we had when we designed this. This is more of a feature, but I thought it's worthwhile, right? In many applications, you have the need to get data out of different systems. And again, it generally requires you pushing logic up to your application tier. So what we've done with HANA is we've built in like a virtual logical database model where we can actually connect HANA to other data sources. And those data sources can be structured or unstructured or even APIs. And fundamentally, the application just sits on top of what it thinks is data, right? So it's kind of a logical data mart model that we've implemented here. Deployment-wise, you can scale up and scale out. It's your choice. What you can see here is that you can dramatically simplify the architecture. So I've talked about having the application paradigm and the database paradigm in the same logical system, right? So if you look at the left-hand picture